we got an interesting question. You're expected to integrate integral x to the power of 4 divided by x negative 1 times x squared positive 1 times dx. Now what I wish to do is I would like to rewrite this as integral x raised to the power of 4. I would like to add a 1 and subtract a 1 divided by x negative 1 times x squared positive 1 times dx. Then I would like to club negative 1 with x raised to the power of 4. The reason is I would like to actually get rid of this term. Okay, that's my objective. So for that I am actually performing this manipulation. So this is going to be x raised to the power of negative x raised to the power of 4 followed by a negative 1 and positive 1. So I will club these two as I just mentioned times dx divided by x negative 1 times x squared positive 1. Now this can be rewritten as integral x raised to the power of 4 negative 1 divided by x negative 1 times x squared positive 1 over x negative 1 times x squared positive 1 times dx. Now a squared negative b squared is a negative b times a positive b. So x to the power of 4 negative 1 can be rewritten as x squared raised to the power of 2 negative 1, which can be again rewritten by this formula as x squared negative 1 times x squared positive 1. So take this and substitute it here. So this is equal to integral x squared negative 1 times x squared positive 1 times dx divided by x negative 1 times x squared positive 1 positive integral dx over x negative 1 times x squared positive 1. Now x squared positive 1, x squared positive 1 gets cancelled. Now again x squared negative 1 can be rewritten as x positive 1 times x negative 1 or x negative 1 times x positive 1. So this is equal to x negative 1 times x positive 1 times dx divided by x negative 1 positive integral dx divided by x negative 1 times x squared positive 1. X negative 1 gets cancelled, giving you integral x positive 1 times dx positive integral dx over x negative 1 times x squared positive 1. I'm not going to integrate it this as of now. What I wish to do is I would like to solve this first. So I would consider this. So I'm going to state here consider integral dx over x negative 1 times x squared positive 1. Okay, I'm going to use partial fractions. So I'm going to split 1 over x negative 1 times x squared positive 1 as ax positive b divided by x squared positive 1 positive c over x negative 1. Okay, so if you were to cross multiply, you get ax positive b times x negative 1 positive c times x squared positive 1 is equal to 1. Now what I would do is I would collect the coefficients. Okay, if you want you can directly substitute. Say if you want to substitute, let x be equal to 1, this goes off and you get x 2 times c is equal to 1. So therefore c is equal to 1 over 2. So that is easily obtained. Now next you substitute, let x be equal to 0. X is equal to 0, a goes off, this goes off, so you get negative b, this goes off, x is equal to 0. You get c is equal to 1, but c is equal to 1 over 2. So you substitute negative b, positive 1 over 2, negative 1. This means you push this 1 over 2 to the other side, you get 1 negative 1 over 2 is equal to negative b. This will give you 1 over 2 is equal to negative b. Therefore the value of b is negative 1 over 2. Okay, you take the negative sign over to this side or you multiply both sides by negative 1, you get b is equal to negative 1 over 2. Now you take one random value, let x be equal to 1. So if you substitute x is equal to 1 over here, in fact you don't have to take x is equal to 1 because we've already taken x is equal to 1. Probably x is equal to negative 1. Okay, that's fair enough. You substitute negative 1, you get negative 2 times b, and you have a negative 2 and you have a negative, so it's going to be 2a, right? Positive 2a. So positive 2a is equal to negative 1 is positive here, so 2 times c. So I will say positive 2 times c is equal to 1 on the left hand side. Now b is negative 1 over 2, you substitute there, that would give you positive 1. And I'm looking for the value of a. I know the value of c. C is 1 over 2. c is 1. So you add these two, you get 2. So 1 negative 2 is equal to 2 times a. So negative 1 is equal to 2a. Therefore a is equal to negative 1 over 2. So I got the value of a and b and c. So if I were to take this as 2, I can rewrite this as, so therefore 1 over x negative 1 times x squared positive 1 is equal to a is negative 1 over 2 times x and b is negative 1 over 2 divided by x squared positive 1, and c is positive 1 over 2. So 1 over 2 divided by x negative 1. Now you take all these things and you have to write this as 1. So I'm going to move to this side. Okay, so therefore 1 is equal to, so on one end you have integral x positive 1 times the dx, and on the other end you have this. So I'm going to place these values. So I'm going to take negative 1 over 2 out. So if I were to take negative 1 over 2 out, you get x positive 1 times dx divided by x squared positive 1. So this is one particular term. You have integration, and then positive 1 over 2 integral dx divided by x negative 1. Okay, so this can be split again. So if I were to split this, x positive 1 times the dx, this is negative 1 over 2 integral x over x squared positive 1 times the dx positive integral dx over x squared positive 1. This is positive 1 over 2 integral dx over x negative 1. Okay, you have 1 over 2 here, and this is going to be x squared over 2 if I were to integrate the first component, and followed by integral dx, that's going to be x, and this is going to be negative 1 over 2. Now this is straightforward integration. Now let me show that here. You have x times dx divided by x squared positive 1. Now if you were to take x squared positive 1 is equal to u, you have 2x dx is equal to du. So x dx is equal to du over 2. You substitute x dx du over 2, you have 1 over 2 du divided by u. So that would give you ln u, 1 over 2 ln u. But my u is x squared positive 1. Now actually what you can do is a times ln b is going to be ln b raised to the power of a. So this is going to be ln of x squared positive 1 raised to the power of 1 over 2, which is nothing but ln root of x squared positive 1. So you can utilize that result. So I have just taken this into account. So upon integration, this is going to be ln root of x squared positive 1. That's for the first component, and this is going to be tan inverse of x, and okay, followed by 1 over 2 times ln of x negative 1. In fact, I can push this, I don't have to do that. Let's just simplify all of this. Now this is x squared over 2 positive x, and followed by negative ln root of x squared positive 1 negative 1 over 2 tan inverse of x, and then positive 1 over 2 ln of x negative 1. Can I club these two together? So I club these two together. I write x squared over 2 positive x positive 1 over 2. I'm going to write it as ln of x negative 1 negative ln of root of x squared positive 1. That's one term, followed by negative 1 over 2 tan inverse of x. Now ln of a negative ln of b is equal to ln of a over b. Okay, so by that, if I were to substitute this, this is going to be x squared over 2 positive x, followed by I take a 1. Okay, that's fair enough. So this is going to be positive 1 over 2 ln of x negative 1 divided by root of x squared positive 1 negative 1 over 2 tan inverse of x. Right, now you have a 1 over 2 1 over 2 1 over 2. Probably I can take that 1 over 2 out and write this as x squared positive ln of x negative 1 divided by root of x squared positive 1 negative tan inverse of x. That is one term, followed by a x and a positive arbitrary constant. The steps included, or I would say there are a lot of steps in this particular question that has been done basically to ensure that everybody is in a position to understand what's going on in this particular question. So thank you everybody. We move on.